topic by topic. Slightly later than published due to a few technical problems, but we're going to get going and have a look today at one of these required practicals that comes up, looking at resistors in series and in parallel and what they do. So let's have a look at the sort of things we're going to be looking at. If we look at a circuit which is in series, then we would have a battery. I usually like to make sure that I've got a switch in the system, and the reason I like to have a switch in the system is that it stops my batteries running out. And then we can set up my resistor here in parallel. Now, as I set my system up, then we can put a voltmeter across this resistor. We could put a voltmeter across the other resistor, and we could measure the voltage there to see how they compare when we run these circuits with these resistors in series and in parallel. And here I could put the voltmeter across one or the other, or as we did before, with both, and we can look at and see what happens. So here what we're going to do, we're going to set up this circuit. We're going to set up typically this type of circuit, and we're going to set up having 3 resistors in parallel. And this is where I really should do this with a ruler, but I'm trying to do it quickly. And we're going to put in here a 1 ohm resistor, a 2 ohm resistor, and a 5 ohm resistor. And we're going to have a look. We're going to set up somewhere between, anywhere between 1 and 6 volts through here. What we should know is that the voltage we expect to stay constant, and we would expect the current to be split here. So what we're going to do is we're going to measure the resistance of the resistors individually and then in series with one another, and we're going to see the resistance should be the sum of their individual resistances, and then we're going to play around. Now the wire might get hot, and if it does, then we're basically going to have a little problem. So let's have a look and see what we can do with these resistors. I've got set up here my equipment to try and do this, and I'm just going to bring along my notepad so that I can record what we've got. We've got here our battery power pack. We've got here 2 meters. I've got one set up as a voltmeter, and I've got the other one set up as an ammeter. And then we've got a switch, and we're using a very simple switch here. It is in fact a double switch, but I'm just going to use it because it will stay switched on for as long as I want. We've got then this going into a junction block. And I've got my resistors, 1, 2 and a 5 ohm, so we can have a play with it. I want to show you first of all the circuit works. So we're going to come out of the battery and we're going to make this the negative, and let's just show that this works. So I'm going to replace one of these with a bulb. I've lost all my wires. That was them, was it? That's it. Okay. So let's come out of here into a bulb, and I'm going to go from the bulb into the circuit, and we're going to go back to the battery. And I don't seem to have, again, much working. No, we're going to see if it all works first. I'm going to get rid of all of it to the circuit. I'm just going to test everything works. So I've got my switch, I've got my bulb, just going to always set we've got a simple circuit. I want to check everything's working. I have recharged my batteries, and so what we should end up with is that battery's working. There we are, those. I seem to have a problem with that bit there. That one's working. So yeah, I have a little problem with my battery system. Right, okay, so we've solved the problem. I've got enough here. I've got 3 volts. My bulb is perfectly bright. So that's working. Now let's set up the circuit we want. We're going to measure it first in series. So let's take my different resistors, and I'm just taking all the wires out. So we've got a 1 ohm and a 2 ohm resistor, and we're going to put these in series with one another. So we're going to come out of the switch, we're going to put an ammeter in the circuit. So I replace a wire with the ammeter. I'm going to go into this. We're going to then, let's use red wires now then, go into the 2, and from the 2 I'm going back, and let's see if anything works here. Right. It says my battery is virtually run out. And I've got virtually no amps running through the circuit. I'm still stuck with a circuit that's not working. I have an ammeter that's not working again. Right, there we are. It's set up now. Right, okay, don't let someone else set the circuit up for you. We're coming then into the ammeter, out of the ammeter, and from the ammeter then we're going to run back to the battery. And I have got now a current that we're measuring. Right, let's try a voltmeter. And what I'm going to do is I'm going to put a voltmeter across this. Get the value, that seems to be working, and let's put the voltmeter across this one, and we're getting something working. Right, let's have a look and see what we've got. So we've got here to have a look and see whether the voltage across here and across here add up to the whole thing. So let's look at what I've got. I've got a current here of 7.41 milliamps. That should be the same regardless of where we put it, but we'll try that in a minute. We've got a 1 ohm resistor, I've got a 2 ohm resistor, and over the 1 ohm resistor I can see that over the 2 ohm resistor we've got 1.650. If I put this over the 1 ohm resistor, I've managed to put it round the wrong way. Then I've got 0.682. Let's now take this and put it across from one side to the other. So let's just check which way it's going. We're coming in this side, going to that one, going on. So I'm going to put this one on the far side, this one on the near side, and if we put those together, then I've got moving around an awful lot, 2.0 we'll call it 2.04. It's moving around from 3 to 5. Let's see what we've got. If I can take both of these and add them up, we'll see what I've got. I'm just going to disconnect the voltmeter. I'm going to switch off the circuit. Let's see what these are individually. So I've got 0.682 and I'm going to add 1.650 and that's going to give me, for a total 2.332, and together we should find that it's going to give me the same number, and blatantly I haven't got that number. What we should get and what we do get are different. And at the moment it's giving me 1.9, which is even worse. This is suggesting that I've got some rather poor connector somewhere. And the fact it's moving so much is suggesting that something isn't working quite right. Right, we'll manage as best we can, because these are our results. Now let's have a look and see what happens if we set this up in parallel. We'll change the circuit a little bit. Well, I haven't proved the current is the same throughout. I suppose I could do that by taking this one out of here. Let's put the wire back, and then we'll put it in between these two. It was about 682. If I switch on, considering it should be about the same, we had 741 before, now I've got 7.16, so it is varying slightly, and we could put it the other side. I'll put my wire back, I'm just completing my circuit. I'm going to take that one out, and instead we're going to put in this the other side of this circuit. The lead was not quite long enough. And I really am having a bad day so far with the machinery not working. We've replaced the battery and that had no effect. I'm going to set this as a milliammeter. Dead on about 6. As I said, dead on 6. Look at it turning around. I've got some cheaper meters. I got the more expensive ones out because they weren't working. And let's just see what we can do with my cheaper meters. And it's still moving around quite a lot. Right. Well, I think I'm going to stick with this little one just so I can see what's going on. It's working a bit more reliably, I think, than the one with the battery that's decided to die. as an ammeter. Let's have this one as a voltmeter. I just want to prove it works. And if we put this over here, I'm getting very different readings than I did before. So on my voltmeter, I'm getting across the one, we've got current is 0.59 and the voltage across the one is 0.55, and let's put it across the other one. And I've got 1.2, 3. It's going to stay on the 4 now, isn't it? 1.24. And then let's take this across both. And I've got 1.77, and if I now add up, I've got 0.55 plus 1.24, and that's giving me 1.79, which is tying in much more closely with what we had for the other one. So it suggests that the batteries are going on these, and we've got a problem with them. So that's in series. We've solved the problem, and will you get these sort of problems when you do this at school? The answer is almost certainly yes. Let's look at this now in parallel. So I'm going to take the ammeter out. I'm going to basically break the whole circuit, and let's work out where we're going. I've got an ammeter coming out of the battery. We've got a switch coming out of the other side of the battery, and we're going to go into a, let's make it easier for you to see. Let's take these junction boxes, and we're going to bring this into this junction box and this into this junction box. We're going to put our 1 ohm resistor here, in series, and I'm going to put my 2 ohm resistor also in series. Now, is this working? Well, that does seem to be a problem with my circuit, so let's just try a bulb here first just to see if it's working. And I'm getting a bulb lighting there. And we'll just replace that one and see if we've got a bulb lighting there. It does seem to be a bit brighter, that one, than the other one. I'm always unhappy when that happens. Seems to be about the same. So I've got my resistor going this way, and I've got my other resistor going that way. Let's switch off. Because what I don't want to do is get any of the devices getting hot. Now here we've got a resistor, and we can't see much about that resistor. If you could just pass me the box for a minute. What I've got is a whole load of these resistors, and if I just take out my 200 ohm resistor, if I turn this upside down, I've already taken the bottom off, and you can see that what we've got is a semiconductor resistor at the bottom there. So that's all it consists of, is the terminals connected to the resistor. So it gives you an idea of what it looks like. I've got my ammeter in the system. I can switch on, and my ammeter is going to register here something. That's good. And we want to take our voltmeter, and we now want to have a look at what my voltmeter is across these two bulbs. And across these two bulbs we've got about 1.0, 1.1, still widely fluctuating. One 1.12. Let's put it across the other one. And we should have, in theory, the same amount of voltage going through both, and blatantly we're not getting that. I'm getting quite a variation here with the circuit. So I've got about 1.18, and going back to the other one. About 1.15. Probably not really that much difference really. It's all to do with how bad my connectors are. And it moved up then as I played with the switch. These are very, very crude, simple switches, and they do cause lots of problems. So let's look at this then in parallel. So I've only got at the moment 2 in my circuit, and looking at this in parallel then we can look at my current, we can look at my 1 ohm, we can look at my 2 ohm. So the current, this is in the total circuit. I'm getting different numbers now than we were. So I've got a current of about 1.8. See where it shouldn't be moving. I'm going to call that 1.80. I think we'll do that one. The one across the 1 ohm, then 1.15. Let's set this up and do it on the 2 ohm. One point 1.8. Now what would happen if I put this voltmeter measuring the volts across both resistors? And I get yet a different value. This is now across both, and I'm getting 1.64 set moves. Alright. What are we trying to have a look at in this sort of circuit? We're trying to see and investigate what happens in series and parallel circuits. And this type of system doesn't seem to be working terribly well. There are alternatives. Let's have a look at an alternative way of doing this. So let's take it all to bits, and I'm just going to put that away, and I'm going to get out instead a set of Loctronics which tend to work better. If all else fails, just give up. Right, we're going to try the same thing using a box of Loctronics. I'm just going to move some wires out of the way, we're tidy. And instead I'm going to get out some Loctronics. I'm going to start again with a battery. And we've got a couple of resistors that we can have a look at. Now, the meters on here are not very good. They're a little bit too small to see. So I'm going to use the less reliable digital ones. Everyone seems to think that given the choice of a digital meter and an analog meter, the analog ones are the ones to reject. And I would disagree with that. Right, let's set up a simple circuit. And with this, I'm going to choose two resistors. I'm going to have a 12 ohm resistor, and I'm going to have a 100 ohm resistor. And we can set this circuit up very much like this. I'm not going to put that one in. But there's my system working. I want to show that it works to start with. We've got our two bulbs. They dim. If I only have one bulb in, we know it's quite bright. I'm going to take that line out and I'm going to put the 12 ohm resistor in, and the bulb changes brightness. If I put the 100 ohm resistor in, we can see that the bulb barely lights. Bigger resistor, it's using up more. And there we've got our second one in. Now, what I'm going to do is I'm going to put in an ammeter into the system. And the good bit about the electronics kit here is we can do that. So I'm going to put in my 2 wires. And this is the negative terminal, so I'm going to put in the negative, and I'm going to put in positive, and it's a lot more stable. We've got here a voltage that we can actually use. So I've got a current there I can use, not the voltage. Right, let's see what we've got. This time we've got a slightly different circuit. I've got a 12 volt supply. I've got, coming from my 12 volt supply, we're going to a 12 ohm resistor, we're going to a 100 ohm resistor, and then I've got an ammeter in the place. If I put the ammeter in a different place, we get the same number. I will just show you this. But I'm getting here the same second. So the current here, before we start, 0.11. And then we've got our 12 ohm resistor, and we've got our 100 ohm resistor. Let's work out what the voltage is. Let's take my voltmeter, and I'm going to put this across the 12 ohm resistor. And I get 1.6. I'm going to put this across the 100 ohm resistor. 10.46. And we can put it across both. .06. If I add these up, let's see if it's going to work any better. I've got 1.6 plus 10.46, and that's going to give me 12.06. So I'm getting the voltage split across these two, but it's the same if I put it across both, and that is what I should have seen in the other one. So how do I work out what is the resistance of this? Well, we should be able to work this out using V equals IR. If we rearrange this, and I'll just do this on the other camera. We've got V equals IR. Here we're going to change this to R equals V over I. If I know V and I know I should be able to calculate R, and it should come out as 12. Let's see if in fact I can do that, and hopefully it should work. Right, so my resistance is going to be 1.6 divided by 0.11. let's put this in the calculator. So I've got 1.6 divided by 0.11. Let's keep my fingers crossed, and it should come out at, it says here, about 14.5 volts. Well, am I surprised about this? The answer is no, because these resistors are only made to a certain tolerance. So someone said, yeah, they're about 12 volts. That means they could be as much as 15 and as little as perhaps 9. Depends what the tolerance is on these resistors. Let's have a look at the other calculation. My resistance should be 100, and we've got here my voltage, which is 10.46 divided by 0.11. Let's see what this resistor is going to be. So we've got 10.46 over 0.11, and that's going to give me 95.09. I wrote volts on that one. Ohms. Right, so together I've got this resistance, and it should be this 95 plus 14. Let's just add those up. So I've got my 95 plus my 14.5, it was about that. So that should give me a total resistance, just adding the two up, of 109. We measured the voltage across both over that current. Let's have a look. So this is going to be 12.06 divided by 0.11. And if we do the calculator on this, we've got 12.06 divided by 0.11. And that gives me 109.6. With me not writing all the numbers down, that gives me the fact that these two really added up give me 109 ohms. So let's look at this as a parallel circuit and what's going to happen. In a parallel circuit, we've got the same setup, except I'm going to have my 12 ohm resistor and I'm going to have my 100 ohm resistor. We'll measure the voltage and we'll measure the current. The voltage should be the same. No matter where I put it, the voltage should be the same. The current will change, so we'll try putting in and measuring the current in this circuit. Let's go and have a look at this. I'm going to disconnect everything and start again. Now, for technical reasons, I'm going to make myself a slightly larger circuit than what I possibly need. So I'm going to put my 12 ohm at the top, and I'm going to put my 100 ohm at the bottom. There's my circuit, and what we're going to do is we're going to put my ammeter in the circuit. So what we're going to do is try not to heat it up too much, Philip. We're going to put this ammeter in the circuit, and we've got something. I am going to put a switch in here because it's going to be a lot safer. There's my basic circuit. We're going to put the voltmeter across the 12 ohm resistor. Just try and get it in nicely. And let's see what happens. And we've got 11 and 1.02. So I've got 11 volts going through here, and that's an awful lot for this poor little resistor. And this one I've got the same 11.63. So my resistor here, we've got to try and have a quick look at what the current is. So I'm going to look at the current in different positions. This is the total current, and this is going to give me, I'm going to put a better switch in. It's going to give me 1.02 amps. Let's put this in a different place now. And let's have a look. This is now just going through 1. This is 0.95. Let's position this one down further. .11. Let's have a look at the results. I've done this basically quite quickly because with just a 12 ohm resistor with that amount of power in, it gets quite hot and it will smoke and it will burn out very quickly. So I've been fairly quick at trying to do that and take the readings pretty quick. Again, if I wanted to work out the resistance here, then my resistance calculating then on the 12 ohm resistor, then I've got about 11.63 volts going through, and the current was 0.95. Do the calculation. We've got 11.63 divided by 0.95, and that's telling me I'm getting a resistance of about 12.24. Looking at the other resistor, this is going to give me 11.63 and the current this time is 0.11, much less current going through the larger resistor. And that's giving me 105. But what about the total resistance? I've still got the same voltage, but let's look at what that current is. So my resistance that I'm going to calculate is going to be my total voltage, which is 11.63 divided by 1.02. And a surprising answer comes out. 11.401. In our series circuit, when we put them together, the two added up and they worked out remarkably the same as adding the two resistors up. But when we put the two resistors in parallel, the number that we get here is always smaller than the smallest resistor. Seems odd, doesn't it? That if you actually want to make a bigger resistor, we put resistors together in series. But if you actually want to make a smaller resistor, you put them together in parallel. And that's the concept you've got to try and get from this little practical. We spent then some time having a look at electricity and some of its properties. We've got some idea about series and parallel circuits. Next time we're going to go on and have a look at alternating current and what that does. If you found this helpful, then please like and subscribe, and I will see you same time next week to do more work on alternating current. Take care, see you then, bye bye.